So good morning students, today we will understand about the iteration method. So using this iteration method we can also find the root of any equation. So iteration means nothing but we have to use different iterations, that's why it is known as iteration method. So this video basically covers the basic principle of iteration method that will be used to find the desired root of any equation, and we will use an example. So let us see, first of all we will see what is the basic concept or what is the formula with the help of which we can find out the desired root. So let us see. So we can say to find the root of an equation, to find the root of an equation fx equals to 0, let us say this is equation number 1. To find the root of an equation fx equals to 0, let us say this is equation number 1, using the successive approximations, using the successive approximations equation 1 can be rewritten as, we can rewrite this equation number 1, and this is x equals to 5x, let us say this is equation number 2. So the equation for which we want to find out the root, it can be rewritten as the equation is fx equals to 0, so we are writing it as x equals to 5x. Now the most important point of this iteration method, the root of equation 1, the root of equation 1 is the intersection the root of the equation 1 is the point of intersection of, so the desired root is basically, this is the intersection between the two lines, one is straight line and second is curve. Now we will see this graph. So as we are saying, this the root of equation, this is the point of intersection. So this will be the point of intersection of this straight line, that is y equals to x, and the curve which is y equals to 5x. So this is the point of intersection. So this will be the desired root that we want to find out. So we can write the root of equation 1, this is the point of intersection of straight line y equals to x and the curve y equals to phi x. So these are the two equations which y equals to x and y equals to phi x. So we want to approach at this point. If we see this graph, we will start later on. I will explain that we will start from x and we will go up to further. Now let x equals to x0 be the initial desired root, say alpha. So we are starting from x0, or we can say x equals to x0 be the initial approximation of the desired root. Now we will see if this is initial approximation, then the first approximation is, this is given by, this will be x1 equals to phi x0, means after obtaining the value, this x0 we will put in this, we can say this is 2, so this will be phi x0, and in this way we can get the value of x1. Similarly, we can find out the second approximation. This will be x2 equals to phi x1, and similarly we can say the third approximation is x3 equals to phi x2, and so on. So in this way we can find out the subsequent approximations like x2, x3, x4 and so on, and we will go up to, we can say, the nth approximation. Nth approximation is, this will be xn equals to phi xn minus 1. So this is the generalization. We can say the nth approximation is given by xn equals to phi xn minus 1. So this is the formula by which we can find out the particular approximation. So we can say, let us recall it. So what we are doing, first we are saying that we can say the root of the equation is fx equals to 0, and we are saying this is, let us say this is equation number 1, Now we can rewrite it as x equals to 5x. Let us say this is equation number 2. Now the root, the desired root will be the intersection point. So this will be the intersection point. So here we can say C. So this will be the desired root will be this is the intersection point of these two equations. This is y equals to x and y equals to 5x. So and this is the intersection point. So in this graph we can see that initially we have taken some initial value. This is the initial approximation. This is x0. We start from x0. So we can put this x0 here. So this will be x equals to x0 we can put. So with the help of this x0 we can find out x1. This is the first approximation. And after getting this x1 we can put this again in 5x. We can find out 5x1. So this will be the second approximation. And then we can use this value for the next. This will be x3. Like here we can see this is the x0, this is initial approximation. Then we are finding this value. And then x4 and then x5. Like ultimately we can at this. This is the basic principle of iteration method. Now let us take an example in which we will use iteration method and we will so now we will see the example of the iteration method. Suppose in this example we have to find a real root of the equation cos x equals to 3x minus 1 correct to 3 decimal places using the iteration method. So in this the equation is this is cos x equals to 3x minus 1 and we have to apply the iteration method. Now we will see its solution. So let this fx equals to cos x minus 3x plus 1 equals to 0. Let us say this is equation number 1. Like we were saying in the iteration method, so this is fx. So fx equals to cos x minus 3x plus 1 equals to 0. Now we will find f0. We will put the value of x as 0 and on calculation, this is a simple calculation, f0 will be, this is 2. So we can say, and this is a positive value. Now we will put the value of x as pi upon 2 and it will be minus 3 pi upon 2 plus 1. So it comes out to be negative. So in this way, after getting the value of f0 and f pi upon 2, we can say the root lies between 0 and pi upon 2. So in this it means that we can proceed further in this iteration method. Now this equation 1 can be rewritten as, we can rewrite this equation as x equals to, this will be x equals to 1 upon 3 cos x plus 1. So let us say this is equals to 5x. As we know in iteration method we call it after rewriting this fx, we can say this is 5x. So we are saying this is 5x. So x equals to 1 upon 3 cos x plus 1 equals to, this is 5x. Let us say this is equation number 2. Now it is to be noted here that we will find out, we have phi dash x, it means we will differentiate it with respect to x. So it can be written as phi dash x equals to, this will be the differentiation of this, it will give minus sin x. So it comes out to be minus sin x upon 3 and this will be 0 constant term. So phi dash x equals to minus sin x upon 3. If we find out the value of this phi dash x, so it gives absolute value of phi dash x equals to, this is 1 upon 3 sin x, and this value comes out to be, it will be less than 1. So we can say the root will lie between 0 and pi by 2. So this is a very important point. It means the root lie in this interval, hence the iteration method can be used. Now what we will do further, let the initial approximation, we will start from 0. So we are saying that x0 is 0, this x0 is 0. Now the successive approximations will be, it can be calculated as, so this is the first approximation x1. So x1, this will be phi x0. Phi x0 means we will put the value of this 0. So we will find out phi 0. So we will put this 0 here in equation number 2. So what we are doing, we are putting this in equation number 2. So it comes out to be, so again we can say x1 equals to phi x0, this is phi 0 equals to 1 upon 3 cos 0 plus 1 equals to 0.6667, because the value of cos 0 is 1. So this will be 2 upon 3, 2 upon 3 comes out to be 0.6667. So this is the first approximation. Now similarly we can calculate the value of x2. This is the second approximation. Second approximation can be given as, this will be phi x1. Now this the value of x1 we will use here. So this is phi x1. So we can say this is equals to phi 0.6667. Now we will put this value in this cos again in this equation number 2 here. So this will be cos 0.6667 plus 1. It comes out to be 0.5953. Now we will use this, the value of x2 again. So for the third approximation, x3 equals to, this is phi x2 or this is phi 0.5953. We are putting this value again in the equation number 2. So it comes out to be 1 upon 3 cos 0.5953 plus 1. This value we can calculate from the log table. So you can see this value from the log table. So this is cos 0.5953 plus 1. It comes out to be 0.6093. So this is the value of third approximation. Now we can use this, the value of x to find out the fourth approximation. So this fourth approximation will be x4 equals to phi x3 equals to phi 0.6093 equals to 1 upon 3 cos. Here we will use this value. So this will be cos 0.6093 plus 1. It comes out to be 0.6067. Now this value of x4 will be used to find out the fifth approximation. This is the fifth approximation. X5 equals to phi x4 equals to phi. We are putting this value of x4 here. This is phi 0.6067 equals to 1 upon 3. We are putting this value here. So this is cos 0.6067 plus 1. It comes out to be 0.6072. This is the fifth approximation. Now this value of x5 can be used here. So this is the sixth approximation. X6 equals to phi x5 to phi 0.6072. We are putting this value here. In this way we can again we are calculating this value. So this is equals to 1 upon cos 0.6072 plus 0.6071. So this is the sixth approximation. Now from here these two values, these two approximations are almost same. This x5 and x6 are almost same, because we have to find out the value up to 3 decimal places. So the value of x5 and x6 is same up to 3 decimal places. This is 0.607, this is 0.606, almost same. So we can say the final root will be 0.607. So in this way we have calculated the value of the root.